So, we continue our lectures. Please remember that this is the part 1 of the 4-part course, and where we are doing overview of electric vehicles. And we had started in the last class with chapter 1a. In chapter 1a, what we did was take a IC engine vehicle and said that as we move from IC engine vehicle to an electric vehicle, what parts will go away, what parts will come in. This is what we had done. We had specifically said that we will have to bring in motor and controller instead of the engine. The source of power, instead of being a fuel and injection IC engine, it will be now a battery. And of course, battery will need charger, and we had put charger similar to filling petrol in a petrol tank. We had put that it is filling electricity, putting electricity in a battery, and then the vehicle will move. We had talked about briefly about controller, we had talked about auxiliary power, we had talked about what are the fundamental things that we need to worry about in electric vehicles, just like in any IC engine vehicle. This will be elaborated in much more detail in chapter 2, where we will get into fundamentals of vehicle dynamics. We will look at the torque, we will look at the power, we will look at the speed, we will look at the RPM. All these concepts which we had introduced in chapter 1a will be elaborated in far more detail in the chapter on vehicle dynamics. What we will do is that we will move slightly in a different track now. This is still the introductory chapter, and I call it 1b, where I still give you overview of electric vehicles and the introduction. This we will talk about what is the drive for electric vehicles in India. Why? What are the key bottlenecks? What attracts electric vehicles, attracts the country towards electric vehicle? And we will not just talk about the approach, but also what will make electric vehicles win and why should it win. We will bring in here substantially technology and economics, very simple economics, what is the cost and what will therefore the final operation cost of electric vehicle. This is what we will do, and we will start with a very simple, why is there so much interest of electric vehicles in India? Even though there has been last month or so, there has been few fires and it has been covered in the media, it is becoming sensational news, and it does not stop the march of electric vehicles. What is the fundamental reason why electric vehicles is suddenly becoming so attractive? Note that we started this whole thing in 2016. I was there as an advisor to the Minister of Power, and that is the time we started. That time the attraction was not that strong. Over the years, 6 years, it has built up. Today it is very strong. And what is the key reason? First reason is the 14 of the 20 most polluted cities in the world are in India. We had such a relief when there was a COVID, at least in terms of pollution. But we have opened up, the pollution is back there, and it is increasing day by day. The 36% of NOx, which is extremely harmful, is due to vehicles, and 20% of PM 2.5 emissions in Delhi is due to vehicles. So, finally, if we drive electric vehicle, there is no such emission in the city. So, definitely the pollution will get far less. We are not saying that vehicles are the only polluting elements, there are other elements. Construction, for example, is a major element, we have to worry about it. There are other, if there are power plants, coal based power plants, that is causing a lot of problems. Electric vehicle, this problem does not exist because we have stopped using petrol and diesel. Some naysayers often argue that how is it solving the problem, because you are generating electricity from coal, which is creating pollution, and then you are using electric vehicles. Now, we are very clear that tomorrow's electricity is going to come from renewable energy like solar and wind. That does not have that pollution. The transition is already starting to take place. We will do that in part 4 is on renewable energy. Already the solar based and wind based electricity is cheaper than coal. It is a legacy that we are dealing with. So, that is going to be solved in years to come. But vehicles will continue to be driven by petrol and diesel unless we move to electric vehicles, and we need to move to electric vehicles. There may also be questions that can we move to hydrogen? I want to make it very clear that hydrogen based vehicles are also electric vehicles. Now, the fuel could be electricity stored in a battery or could be hydrogen, it does not matter. Finally, it will be electric vehicle. Here we will specifically talk about battery based electric vehicle, because that is today. Hydrogen based electric vehicle is still too expensive to buy, to operate. Maybe 5, 8, 10 years down the line we will see light of it, but it will be a smooth transition because we would have already converted to electric. IC engine would have gone by then. The second thing you look at India's total consumption of petroleum products. Now, you see a small dip here in 2021, this is COVID. Same thing that you see in our import bills, it's due to COVID. This year it has again shot up, and now the cost has gone up even higher. The way the cost has, it was $140 in 2011, 12, 10, 11, 12 per barrel, and we are lucky that we got it down to $40, $45. It is again back to $100, $110, still not 140, and still our cost of petrol has gone up. That is because taxes are just too much. So, this is the situation where we cannot continue to import, cannot bleed our country, cannot bleed our cities. That is the primary driver of electric vehicle in the country. The other thing that is very often not understood, that basically electric vehicle is 4 times as efficient as IC engine vehicle. IC engine vehicle, you have to start with 20, 23, 24, 21, 22, 23, 24% efficiency. Now, one may recover some of that electricity and they say I can go to 27 to 30, that is a different matter. Recovering is like, in fact recovery takes place as electric, but basic IC engine are not more than between 20 to 24%. We start in electric vehicle at 90%. Motors and controllers are 90%. So, that is one big advantage. So, we will use less energy when we move to electric vehicles, 4 times less energy. It has very few moving parts. All these moving parts will become less and less as the vehicle go up, almost 50 times less moving part, which means the vehicle can last much longer. In fact, one of the tasks that we have taken is, we are taking the old diesel petrol autos, 3-wheeler autos, and we are converting back them to electric. And we are seeing much of the complexity goes away, the things become far more reliable, vehicles will last long. Of course, the industry wants the vehicles to be replaced so that they can sell new vehicles, but finally it will help India, it will help the society, it will help the world if we have electric vehicles. So, with all this, one will say Why not switch? What is the problem? The fundamental problem is energy storage. Its weight, volume and cost, they are by the way related. More the weight means more material is there, more the volume, because more weight is there, more volume, and cost is depends on the amount of materials that are used. So, they are related quantities. So, weight and size, which is energy density, it is called gravimetric and volumetric energy density. Gravimetric is in terms of the watt hour or kilowatt hour per kg, and volumetric is watt hour per liter, kilowatt hour per liter. So, both these energy density are bad, weight and size both are bad. One thing that you need to learn throughout the course, we will be using a very important term, the measure of energy, a unit of energy called watt hour. What is a watt hour? Energy, power is watt, 1 watt is 1 unit, 1 watt, and if that 1 watt is used for 1 hour, it is called 1 watt hour. Watt hour is energy, watt is power. A kilowatt hour, which is considered to be a basic unit of electricity, very often it is called 1 unit of electricity, because our electricity at homes and offices are charged by how many kilowatt hour we consume. So, 1 kilowatt for 1 hour. So, you use 1 kilowatt for an hour, it will be 1 kilowatt hour. So, watt hour and kilowatt hour, watt hour is 1,000th of a kilowatt hour. For example, if a 30 watt bulb is used for 1 hour, you consume 30 watt hour of energy. 1 kilowatt hour is 1000 watt used for 1 hour, or 1 kilowatt used for 1 hour, or 100 watts used for 10 hours. So, all that will result into 1 kilowatt hour. Now, a small home, I am talking about almost 1 room home, typically consumes 2 units of electricity in a day, 2 kilowatts. Some lights, fans, maybe a refrigerator, a television and some cell phone charger. It does not consume that much power. Of course, depends on the kind of devices, some of the fans are very power hungry, in which case it may be a little higher, but 2 to 3 units. That is the reason in a month these very low cost homes have 100 units, and very often the government tries to subsidize, saying first 100 units will not charge. So, that is the unit of electricity. You must understand the unit of electricity. This unit of electricity will be used. This the power is watt or kilowatt, energy is watt hour or kilowatt hour. This will be used throughout the course. So, gravimetric energy density, which is the watt hour per kg. So, if I have a kg of material, how many watt hour can I get? Volumetric is about it is a weight per kg. Volumetric is about liter, watt hour per liter or 1000 cc. Both are very important, because if I want, let us say 10 kilowatt hour, how much will be the volume, how much will be the weight? Weight will add to the vehicle weight, and volume, that much volume of the vehicle will be occupied. So, watt hour per kg and watt hour per liter are two very important part, and the first home assignment that I will give you is go look at the web and look for watt hour per kg and watt hour per liter for petrol, for coal, for wood. What is the watt hour per kg? This question will repeatedly ask, how much can we store in electrical in a battery, in hydrogen fuel cell, how much energy in terms of watt hour will store, and how much will be watt hour per kg and watt hour per liter. So, petrol, coal and wood are the traditional sources of energy. Of course, all of them pollute. We need to understand what is the volumetric and gravimetric energy density, and what is a volumetric and gravimetric energy density in today's batteries. That is what we will compare. And this number, you please do this, look at the search a bit, it is there now on the, easily do a Google search or whichever search engine you want to use, you will find the answer. And here I am more or less giving you the answer. It is a very interesting diagram. I do not remember where this diagram has been taken, but this has been there for long. Look at this number, watt hour per kg. Look at the petrol and diesel, you are talking about 12 kilowatt hour per kg. 1 kg of petrol or diesel has 12 kilowatt hour of electricity, 12 units of electricity. Even in terms of volumetric, it is almost 10 kilowatt hour per liter. So, 1 liter 1000 cc is all that you require. And remember, 1000 cc is 10 centimeter by 10 centimeter by 10 centimeter. That has 9 to 10 kilowatt hour. As opposed to that, look at the lithium ion battery. Look here for the lithium ion battery. What are you talking about? Not even 1 kg, 200, 300 watt hour per kg, 0.2, 0.3 watt hour per kg, and slightly, maybe a little more than a kilowatt hour per liter. But it is not just lithium ion battery. Compressed air, hydrogen, which we are talking about in future, you see even worse. It is even lower watt hour per liter. Volume wise, in weight wise is slightly better. So, it is a 1 to 2 kilowatt hour per kg. If we do liquid hydrogen tank, we get better, but then liquefying the hydrogen has to be done. And then you see all other kind of metal hydrides, methanol, hydrides, coal. Coal is also very good. Liquid hydrogen line 33.3 kilowatt hour per kg, very good liquid hydrogen. But in terms of kilowatt hour per liter, it is still high. So, this is what we need to start worrying about. Of course, liquid hydrogen will require a tank. Tank is will have to be strong enough. So, metal tank, that will add to the weight. So, this diagram is a very interesting diagram, keep this in mind all the time. There is another important diagram. The very important thing is what has happened between 2010 and 2020. 2010 electric vehicle was not there, people could not even conceive of it. By 2020 it has made it happen. Why? You see the energy density, this is in watt hour per kg. We were about 100 watt hour per kg in 2010, and we have gone to almost 300. In fact, we are less than 100. It has gone. Different technology have come up, NMC, NMC 811 has taken us all the way to 300 and even higher now, 320, 330. So, energy density has tripled in 10 years. Now, what does it mean? I require that much less amount of material. So, cost will come down, and therefore, you see the price falling. Well, price falling has even been sharper from 2010, from $1200 per kilowatt hour, it has gone to $135 per kilowatt hour. As more and more energy density increases, prices will be falling more. This is something that you have to learn. You have to therefore look at 500 watt hour per kg tomorrow, 1000 watt hour per kg. We are still not anywhere close to 12,000 watt hour per kg, but 1000 watt hour per kg is conceivable. Maybe it will take 10 years, but this is something that we really need to watch out for. So, today as I told you that today's energy density for NMC and NCSL is 250 to 300 watt hour per kg. This is what we use today. Of course, LFP cells has 150, LFP cells cannot go far higher than that. There is still some interest because they are cheaper, there are a lot of plants which have been built and therefore they are underwriting the capital cost, and it is a less complex technology. But this is only a transient technology, you have to move to 300 watt hour per kg whether you like it or not. And now already talks are going on between 400 to 500 watt hour per kg. Now two things that are being done, first is NMC with graphite anode. Anode has more and more instead of graphite silica. So it was graphite and silica you mix, your energy density goes up. Even in cathode, you make a nickel rich cathode and reduce the cobalt, you see energy density going up. Volumetric energy density 500 watt hour per liter, and you see the price as the energy density keeps on going up from 80 to 400, the prices also keeps on falling down. So that is what we are seeing. Higher energy density, of course. So higher energy density is extremely important for lowering the prices, and that is what the innovation gives us. But what does higher energy density means? It has more energy in a small volume, and if something goes wrong, that energy will be like a bomb. So it will have a higher safety concern. But if you now hear about battery fires, you will sort of say, oh, because high energy density and therefore result into fire. But remember that petrol is 12,000 watt hour per kg, which is 25-30 times higher. Actually, at one time petrol was very dangerous. Smallest spark, whole thing will blast. We have learned to tame it. This is the period we are learning to tame batteries. So, it is a learning curve, but we are getting better. And I want to again point out, cost of battery is inversely proportional to its energy density, and it is a main driver for cost reduction. Why? Because higher energy density basically means I need lower amount of material for same kilowatt hour of battery. I need lower lithium, lower cobalt, lower nickel, lower manganese, lower graphite, and all this help me. Where do you go from here? As I pointed out, petrol density is 12,500 watt hour kg. Now, I have already told you that electric vehicles are 4 times more energy efficiency. So, I require 4 times less watt hour. So, I should compare with 3000 watt hour per kg. But even 3000 watt hour kg, my battery is 300 watt hour kg. So, we are 10 to 12 times higher in terms of weight for same kilowatt, same energy as compared to petrol. In terms of effective, actually we are not 10 to 12, 50 times, but 4 times get subtracted because we have higher efficiency. Size wise we are 5 to 6 times higher. That is the number which will keep moving. For example, if it becomes 500, we will not be 10 to 12 times, we will move like 7 to 8 times. Becomes 1000, we are down to 4 or 5 times. Okay. And you should see next 10 years, 12 years getting close to 1000. Okay. I think with that we are trying to give you a home assignment. What is a watt hour kg and watt hour per liter for petrol, coal and wood. And for example, that is the question number 1. In fact, I have the answer also for petrol, but you need to find out for coal and wood. So again, search for it. I have given you on the diagram also, but it is there on the website. You ask this question, look for it, get to a search engine and you will get the answer. There is a second question. Take a decent size 4-wheeler, consumes 15 kilometers per liter. Not very large size, not very small can do better, but more or less any slightly 4-wheelers will take 15 kilometers per liter is good. Equivalent EV may consume 150 watt hour per kilometer. Battery cells used are 250 watt hour per kg and 500 watt hour per liter. This is number, and use data in table that petrol energy density is that and watt hour per liter is that. Compute the ratio of energy and efficiency of EV and ICE. EV and ICE vehicle. Okay. So, using this compute ratio of battery weight and petrol weight per kilometer of travel by two vehicles. So, you will see suddenly battery weight is big pushback. Compute ratio of battery volume and petrol volume per kilometer of travel by two vehicles. Petrol energy is 45 megajoules per kilogram. Look at the web for energy conversion. I have given you in megajoules per kilogram, convert that and convert that to what is energy per kilogram, watt hour per kilogram. I have given you some number, you should be able to answer this assignment. So, this is a very short introduction. We will come to the next part in a minute. There is a second question that I am asking. I drive my vehicle. I have purchased a battery. I charge the battery and then I drive. So, I say per kilowatt hour I can drive, let us say 10 kilometers or whatever number of kilometers. What is the cost per kilometer? For that I need to find out what is the cost per kilowatt hour of usage of the battery. Now, I cannot just take electricity cost. Electricity cost per kilowatt hour will be 5 rupees, 6 rupees, but there is this cost of battery. This is a capital cost, one time cost and high cost. So, I have to take depreciation and interest of that battery because it has a finite life. Every time I use it 1 kilowatt hour, how much money am I spending in terms of depreciation and interest rate. So, for the answer you have to first ask that storage, the battery that you are using, how many times can you charge discharge? Take 1 kilowatt hour battery, how many times I can charge discharge? 1000 cycles, 1500 cycles, 500 cycles? That question is very important. Second, I start with let us say 1 kilowatt hour. As I start using it, the battery storage capacity keeps on reducing. Remember that I mentioned it. I need to worry about that because I could use 1 kilowatt hour in the beginning, I cannot use it after some time. So, I need to take that into account also. Then as I told you, I have to take the capital cost, depreciation and interest. Will require an understanding of lifetime usage to compute depreciation and interest. And then of course, I have to take the operational cost, fuel cost. Can one learn to compute cost per kilowatt hour of a usage of different types of energy storage and compare with cost per kilowatt hour of energy sources. Of course, to this we really have to add the environmental cost. We very often do not take into account, but today when the global warming is taking place, we cannot ignore it. We have to talk about, can therefore the battery be fully recycled? Petrol will give rise to pollution, environmental cost has to be taken into account. Battery, electricity does not give any emission, so that part there is no problem. But the battery per se, say after 1500 cycles, if am I going to throw it or am I going to recycle it? So, all these questions we will try to answer. Battery capital cost I just am giving you. Now, later on we will learn to calculate this. This is in chapter 3, we do it in great detail. Chapter 3 we will do it. Battery cost comes out to between 12,000 to 15,000. per kilowatt hour for let us say some decent size 5 to 10 kilowatt hour battery today in India. For smaller battery it may be 20,000 rupees per kilowatt hour, but in a later detail we will get into it. This is important. So, there is a 12,000 to 15,000 per kilowatt hour battery. We need to take the depreciation and interest cost of that, and for the lifetime of the battery a number of times we charge discharge.